Hola, los muchachos grande. Now, a little review for you on states of matter, gases, liquids, solids. So this unit, this subunit of the entire first unit, I break the class into three sections, one-third, test. So our first part of it is on forces, intermolecular forces in particular. Matter of fact, tonight, if we had met, this would be about intermolecular forces. Some other things we need to go over, but that would be the important thing now. So, but before we can talk about intermolecular forces, as opposed to intramolecular forces, we have to remember what solids, liquids, and gases are all about, because we're going to find out later on that the reason things are solid, liquids, and gases at room temperature are because of the intermolecular forces. So we need to go over those. Quick review. So let's see. I'll go with solids. Nah, I don't like that one. This one's dying. This one's losing it. Okay, the basket's way over on the other side. I can do this. Oh, just missed to the left. You should have seen it. It was. Never mind. Try this one. Solids. Oh, that's what I'm talking about. Willis. Okay, solids, liquids. I suppose we should. All right, can you see it now? Then gases. Quick review. What makes a solid a solid? How do you define it? Let's say that some alien person comes from a different world out there somewhere from the Milky Way and lands, and they don't have any solids on their planet. Okay, they just got liquids and gases, and they say, humanoid, what is the solid of which you speak? Please define. Do not understand. Okay. You say to the alien person, well, a solid is something that has blank and blank. Okay. Okay. You know what a solid is. You do. You know this is solid. Okay. Well, what is it? What about the shape? What about its volume? Doesn't change. Remember, definite shape, definite volume. Solids have a definite shape and definite volume. Yes, they do. Definite shape, definite volume. Here's my container of Clorox wipes, which I still have a butt ton of these things left. You go back a couple months ago, this thing's like gold. I could have sold this and retired. Not anymore. So look at it. There's a definite volume to it. I don't know what the volume is. We could figure it out. We could do some water displacement or, the shape, that cylindrical shape. Okay, it's definite. It just is. It doesn't change. The shape doesn't change. Unless you physically change it. You take a saw and cut it in half or something like that. Okay. What about liquids? Liquids. So you have to define a liquid. How do you define that? Water. Good high quality, made in America, H2O right there. High quality stuff. What's the shape of that? Well, it's the shape of the container. Well, if I take this and pour it into a graduated cylinder, it'd be thinner and longer. It'd be graduated cylinder shape as opposed to beaker shape. So what do liquids do? They take the shape of their container. Okay, yeah, you know this. You know this. We're just reviewing it, so I call it a review. You know this stuff. So liquids have no definite shape, but they do have a definite volume to it. Certainly, if I took that liquid, which was probably about, what did I have in there, about 300 milliliters, and I poured it into a graduated cylinder, it would still be 300 milliliters, so it's a definite volume to it. All right, and then gases. Come on, you know. Gases have no definite shape or no definite volume. If we had some helium in a helium balloon, the volume of the helium is the volume of the balloon, and it's balloon shaped. If we take the helium and we let it go in the room, what happens? The helium disperses. I mean, it's lighter than air, so it disperses to the top. but it would now lay across the ceiling. It would be ceiling shape with a much larger volume to it. So there's no definite shape or volume to these. So this is no definite shape and no definite volume. Ditto marks, of course, being the same as above. All right, so that's a quick review of what they are, characteristics of them. Okay, a solid. Actually, the definition of a solid, this is interesting. Okay, we'll go into this in another video, but I'll mention it now. Glass is technically not a solid, and the reason for that is glass over time doesn't have a definite shape. Over time, glass is called a very viscous liquid. I'll go into this later, actually, in this later today, what would be today, and it has a definite, doesn't have a definite shape, because what happens is it begins to slowly flow over time. It's called a very viscous liquid, so its shape changes. If you look at very old windows, hundreds of years old, they are actually thicker at the bottom than they are at the top, because over time, the glass has flowed. And if you have flowage, I like that word, I made it up, flowage. You have a liquid or a solid, that's liquids and solids can flow. So interesting that glass is, most people think as being a solid, but it's actually a liquid, a viscous liquid. Gases can be compressed, which means their density is very low. They're compressible. You can compress them very easily. Put a little pressure on them. Remember our gas laws, a lot of pressure, you decrease the volume. So compressible, not very compressible, but there is some compressibility to liquids. We consider these non-compressible for the most part, unless it's something like styrofoam, which is filled with a lot of air, and then it can be compressed somewhat. So for the most part, these are generalities here. Not compressible, compressible, and very compressible. Not very dense, okay, more dense, most dense for the most part. Not every time. We'll soon see that water is weird, because water, solid water, ice, of course, will float in liquid. Well, you know that. Of course you know that. But most things, the solid phase of it will not do that. Most solid phase will sink in the liquid phase. Okay? Try that with alcohol. All right? Take some rubbing alcohol. Put it in an ice cube tray. Put it in the freezer. Freeze it. Okay? Well, you might want to make sure you label that so nobody uses your ice cube for their drink. Okay? And then take it out, put it into your glass of rubbing alcohol, and it's weird. Your brain goes, wah! What just happened? Because you're not used to seeing that. But try that at home, not for professionals only. Okay. All right, so there is some general characteristics that we need to know about solids, liquids, and gases as a review. And now we're ready to get into intermolecular forces.